morning everyone. Today I am going to handle the 10th class physics, that is concave and convex lens. Now we are going to study the concave lens. What is a lens? A lens, it is a transparent medium. Here are you seeing a transparent medium? The transparent medium which is bounded by two curved surfaces is called lens. We are having the different types of lenses, that is biconcave, biconvex. Now today we are going to study the biconcave lens. Why we are calling it as biconcave means it is bounded by two concave mirrors, so it is called as biconcave lenses. In biconcave lens, the reflecting surface is curved inwards. Yes, in these lenses we will see the refraction. Refraction means bending of light ray. Why the light ray gets bent? Why? Because it is changing its medium. Now we have taken a biconvex lens. On this biconvex lens, we are focusing a parallel beam of light. When it undergoes refraction, all the refracted rays intersect at a point. We will call it as focus. In biconvex lens, all the refracted rays gets intersect. This is biconcave lens. In biconcave lens, the refracted rays will not intersect, they will diverge. Now we will see the image formation in biconvex lens. Here we have taken an object as a flower vase. This is a biconvex lens and it is a screen. Now we are taking the three rays from the flower, and these three rays gets refracted and converge here. This is nothing but the image of the flower. In the image of the bottom of the object. Here also I am taking the three rays. These three rays gets refracted and form an image here. Means in biconvex lens we will get the inverted images. Now see the image. Here the flower is at the top and here you are seeing the image at the bottom. Always in biconvex lens we will get the inverted image. When the object is nearer to biconvex lens, in that case we will see the erect image, virtual image and enlarged image. Whereas in other cases, in all the cases you will see the inverted image, real image. See here, what do you mean by real image? Means when the image is captured on a screen, we will call it as a real image. Now this is a biconcave lens. In biconcave lens, here we are taking a parallel rays. When it undergoes the refraction, the refracted rays gets divergent. They will not intersect at a point. Yes, here we are drawing one more image formation for biconvex lens. Here I have taken a biconvex lens. Here I have taken the object as light. From this light we are taking two rays. These two rays undergoes the refraction. As it is a biconvex lens, for a parallel it should pass through the focus, and when it is passing through the optical center, the refracted ray also passes through the optical center. So the image formation of the filament will be here. In this case, are you seeing the inverted image? Yes, you are seeing the inverted image, and this is captured on a screen, so it is called a real image. Here it is a biconcave lens. On this biconcave lens, we are instanting a parallel light, and these light ray gets refracted. They will not converge at a point. Here, now we are studying the image formation of biconcave lenses. Now we have taken a biconcave lens. Here is our object. When the instant rays falls on a biconcave lens, it will undergoes the refraction. The refracted rays gets diverged. If the refracted rays gets diverged, we won't get the image of the object. See here, there is no image. So what we have to do? Then we have to extend the rays. We have to extend the refracted rays at the back of the lens. Now the refracted rays get intersect. This is the image formation of the object, but it is a virtual image. Why? Because the image is not captured on the screen. The image is captured by extending the refracted rays, so it is called a virtual object, and it is an erect image and enlarged image. These are the characteristics of the image formation in biconcave lens.